All right, section 2.4, more about linear equations. So today we're going to talk about point-slope form to start off with. And so point-slope form, the equation of a line in point-slope form through a given point with a slope m. So if I provide you with a point and the slope, you can start by putting your equation of a line in point-slope form, and then if need be, simplify this down into slope-intercept form. So let's take a look at this first example. So right now they provided me with the point -5, 2 and a slope of 3/5. So we got x1, y1, and this is our slope. We're going to put this into point slope form, which is y minus y1 equals m times x minus x1. So we're going to substitute these values in where they need to go. So y minus y1 is 2 equals 3/5. X minus x1, so x minus a -5 would be plus 5. So this is our equation in point-slope form. You might remember from Algebra 1, if we wanted to, we could quickly turn this from point-slope form into slope-intercept form. And that's, well, we'll take a look at that real quick. To do this, we just need to distribute our slope. So we've got 3/5 x plus 5. Oops, sorry, not plus 5. It's going to be plus 3 because 3/5 times 5 is 3 equals y minus 2. Then we're going to add the 2 to the other side, and we get y equals 3/5 x plus 5. So this is our point-slope form. On the left, this would be slope-intercept. So you can kind of move between the two as necessary. All right, let's look at the next example. This time they give us a point of 7, -1 with a slope of -3. So same idea here. We want to put this into point slope form. So we've got x1, y1, and we're going to plug those values in. So we've got y minus a -1, so that'd be plus 1, equals -3, x minus 7. This is your point-slope form. But remember, if we want to put this in slope-intercept form, we can simplify this. We would distribute the -3, so it's -3x plus 21 equals y plus 1. Then we would subtract the 1, so y equals -3x plus 20. And remember, this is slope-intercept, and this is your point-slope form. This time we're looking at writing an equation given 2 points. So they didn't actually give us the slope yet. So that means before we can put this into point slope form, we're first going to need to find the slope. And so remember, your slope formula, if you don't recall, is y2 minus y1 over x2 minus x1. So for this problem, we've got x1, y1, x2, y2. So we're going to take 8 minus 2 over 5 minus 3. 8 minus 2 is 6, 5 minus 3 is 2, so our slope in this case is just 3. So this is m. Now we can take this value of m and either point in this case and write these into point-slope form. So keep in mind your point-slope form equation, y minus y1 equals m times x minus x1. When you're plugging into point slope, either point set could be x1, y1, so it's kind of preference. I'm just going to use the first point here, the 3, 2. So y minus 2 equals 3 times x minus 3. And this is point slope form. We could also simplify this down, but I'm not going to for time's sake right now. All right, second problem, same idea. Let's find our slope. So we're going to take y2 minus y1 over x2 minus x1. So since it's minus a -5, we just change it to plus 5. So we've got 7 over 5, or 7/5 is our slope for this problem. Then we're going to take this point, and we're going to put this into point slope form. So remember, that's y minus y1 equals m times x minus x1. So we've got y minus 0 equals 7/5, x minus a negative 5, so that'd be x plus 5. And we can simplify this down to make it look nicer. You can get rid of the minus 0 and just have this. Or you can keep simplifying and put it into slope-intercept form. Another way to write an equation is in what they call standard form. So standard form for a linear equation is ax plus by equals c, where a, b, and c are real numbers, and a and b are both non-zero. We mentioned a and b and c being real numbers. The other thing is you do not want fractions or decimals in your standard form. So at the end of the problem, we're going to have to eliminate those items. They need to be whole numbers for the most part, or integers. So for this problem, we want to put this into standard form, which we know puts the x and y variables and their quantities on one side and a constant on the other. So if we're looking at this first example, this is slope-intercept form, so it's not quite right. So what we're going to do is we're going to take this and we're going to move the 3/4 x to the other side. So I'm going to subtract 3/4 x. And so with this, I end up with, in this case, negative 3/4 x plus y equals negative 5. I said before that I don't want fractions, so now I have to figure out how to get rid of this 3/4. Well, to get rid of the fraction, we're going to multiply by essentially what's in the denominator through the entire problem. So in this case, it's 4. So we're multiplying everything by 4. So we're going to see it cancel here. The 4 is going to apply to the y and the negative 20. So our answer, when all is said and done, is 3x plus 4y equals negative 20. In this example, we're going to do the same thing. We should notice we have decimals here. We'll talk about how to get rid of decimals in a second. But let's just start off by getting the x and y on the same side, because we want to put this in standard form. So the goal here would be, let's move the 9.1x to the other side. So I'll subtract 9.1x from both sides. So we've got negative 9.1x plus y equals 3.6. From here, the goal would be to get rid of these decimals. And notice that both decimals have a value in the tenths place. So we just need to move that decimal over one place. The easiest thing we can do is multiply the entire problem by 10. And so when we multiply everything by 10, we're going to end up with negative 91x plus 10y equals 36. So here we're looking at using the intercepts to graph these lines. We can graph from slope-intercept form. That's easy. You plot a y-intercept, apply your slope. But now we're talking about how do you graph from standard form. Well, one of the easiest ways to graph from standard form, other than rewriting the equation, would be to use the intercepts. So we have to find our x and y intercepts. So if we're looking for our x-intercept, the easiest way to go about this would be to plug in 0 for y and see what remains for x. So we're going to take 3x plus 5 times 0 equals 15. Well, 5 times 0 is just 0, so that disappears. So we've got 3x equals 15, so x equals 5. So our x-intercept is at 5. Cool. Then we want to try to find our y-intercept. So we're going to do the opposite. This time we're going to plug in 0 for x, solve for y. So 3 times 0 plus 5, y equals 15. This becomes 0, so 5y equals 15. Divide by 5, y equals 3. And so now all we need to do is plot these 2 points. So our intercept for x was 5, so we go over to 5. Intercept for y was 3, so we go to 3. And now what we need to do is just connect them. So our line would look something like this. Hopefully I can draw this line straight. Nope, not quite, but close enough. There we go. And so this would be our line. And so we graphed it using our intercepts. Let's try this one more time, this time with the second example. So let's start by finding our x-intercept. Find the x-intercept, plug in 0 for y. Anything times 0 becomes 0. So in reality, we're left with 2x equals 8. Divide by 2, x is 4. That's not how I wanted that to draw. There we go. Then we're going to find the y-intercept, this time plugging in 0 for x. So that's going to leave us with negative 4y equals 8. Divide by negative 4, y equals negative 2. And so to graph this, we're going to plot those 2 points. So x-intercept at 4, y-intercept at negative 2, and our line looks something like this. So here we're looking at parallel and perpendicular lines, and you might remember some of this from a previous class. The slopes of parallel lines are equal, so parallel lines have identical slopes. The slopes of perpendicular lines are negative reciprocals of each other, or you can say opposite reciprocals. So if your one line has a slope of 1/2, the other slope would be negative 2/1. That's opposite reciprocals. So parallel lines mean they have the same slope, perpendicular, opposite reciprocals. So here I want to write the equations of parallel and perpendicular lines. So the first question says, what is the equation of each line in slope-intercept form? And the first one they want us to do is they want us to write the equation of a line parallel to y equals 6x minus 2 through the point 1, negative 3. Well, to do this, all I need to know is, since I'm talking about parallel, I'm going to take the exact same slope they used here. So I know that m is 6 in this case. And I've got my x1, y1 points of 1, negative 3. So I'm going to start by putting this into point slope form. So I'm plugging in this information. So that means I'm going to get y minus a negative 3, so that'd be plus 3, equals 6 times x minus 1. They asked for our answer in slope-intercept form, so I have to simplify. So I'm going to distribute the 6 here. So that's 6x minus 6 equals y plus 3. Then I'm going to move the 3 by subtracting it. And so my answer, when all is said and done, is going to be y equals 6x minus 9. I know these two lines are parallel because they have the same slope. So I think I did it right. So I think we're good. All right, let's look at another example. Here I want to know, what is the equation of a line perpendicular to y equals negative 4x plus 2/3 through the point 8, 5? Well, if we're talking perpendicular, that means we're not going to use this as it is. Instead, we're going to change it. We want the opposite reciprocal, so we're going to flip it and change the sign. So our new slope should be 1/4. And then we've got our x1, y1 point, which is going to be 8, 5. And so this is the information we're going to use and plug into point slope form. So we're going to plug this information in. We've got y minus y1, so y minus 5, equals 1/4, x minus 8. And so at this point, we just want to now convert this into slope-intercept form, so we're going to distribute. So that's 1/4 x minus 2 equals y minus 5. Then we're going to add 5 to the other side. And so if we've done this correctly, we get y equals 1/4 x plus 3. And because the two slopes are opposite reciprocals, I think we did a good job, and I think we did it right. All right, one more example. This time we want to write an equation parallel and perpendicular to the line given through this point. We want one equation parallel and one perpendicular. Okay. But there's a problem. This particular equation is not written in slope-intercept form, so we have to find its slope by rewriting it. So the first thing we're going to do is we're going to move the x over, so that's going to give us 2y equals negative 4x plus 7. Then I'll go ahead and divide by 2, and I get y equals negative 2x plus 3.5. So now that I've rewritten this, I can now look and see that this is the slope of the line I need to either be equal to or opposite reciprocals of when I go to write my two equations. So I'm going to go ahead and start by writing, let's go ahead and start by writing the parallel line. Well, we know we've got y minus the y1 they gave us, so y minus negative 2 would be y plus 2. equals our slope. It's got to be the same, so negative 2 times x minus x1. All right, and so we're almost there. We've got the parallel line in point slope form. We just need to distribute this in order to simplify it down to slope intercept. So this is going to give us negative 2x plus 8 equals y plus 2. We'll subtract 2. And we're going to get y equals negative 2x plus 6. So there's our parallel line equation. Now we'll write the perpendicular line. So the start is very similar. Y plus 2 equals, and then we need our slope, but then we have x minus 4. Remember, for perpendicular, we're looking for the opposite reciprocal slope to negative 2. So that's going to be a positive 1/2. And then we just need to simplify this down to put it in slope-intercept form. So we've got 1/2 x minus 2 equals y plus 2. We'll subtract 2. And we're going to get y equals 1/2 x minus 4. And so we've got an equation parallel, and we've got an equation perpendicular.